We are very excited to host this session, bringing the gap of HPC and AI, AMD and VDURA's scalable AI reference architecture. Well, that's a mouthful. We're going to explore how AMD and VDURA have come together to define a reference architecture that's really focused on performance and scalability. I'm Samantha Clarke. I am the VP of Strategic Partnerships for VDURA, and I'm really personally excited about this AMD partnership. I think AMD has an incredible leadership in the CPU, DPU, and now the GPU market. We'll talk a little bit about the news from this last few weeks. We are a exciting data storage platform, parallel data platform based on an AMD CPU platform. So very, very synergetic. And we have created a scalable reference architecture to help organizations adopt AI easily at scale. I'm really excited to be joined by Sachin. He is the Global Strategy and Operations Lead for AMD. And also, we got an upgrade from the original agenda on the VDURA side, Girard, who is our VP of Product for VDURA. During the session today, we're going to cover a little bit about the market. I think it's moving so fast. It's always great to hear from organizations like AMD. And obviously, we are very, very focused on how the market shifts are moving and how we get ahead of them. And then we'll talk through the reference architecture and how it helps organizations and what we focused on in terms of the reference architecture key points like performance, of course. We'll talk a little bit about some customers we're deployed in and also how you can engage with us, of course. We'll save some time for questions at the end, so please do ask questions in the chat and we will bring them up at the end. So first off, let's have a little fun. Sachin and Chris, can you please share a little bit about your roles and why you're excited today? And then as a fun bit, can you share your favorite AI app that you're using today?
Yeah, I can start. Samantha, thanks a lot. So I'm Sachin Hindupur. As Samantha said, I work in AMD Global Strategy and Operations Leader. I've been with AMD close to around 4 years now. And prior to that, I was working in various big tech firms. So we're excited to be over here for this presentation. And oh yeah, my favorite AI app is ChatGPT. Yeah.
Perfect. Mine too. Go ahead, Chris.
Thanks, Sam. Hi, everyone. Good day. Again, my name is Girard. I'm VP of Product. I'm really excited to be here, really excited to be working with AMD on one of our closest collaborations here at VDURA. I've been in the HPC and AI space for well over a decade, mostly in storage and file systems. So glad to be leading the charge here at VDURA in that regard. Since ChatGPT was taken, I will say that I've started to play with Perplexity's Comet, which is like an AI browser. Still getting up to speed and in all of its capabilities. And then there's another one that I've recently started to work with, which is something called PDF Gear. So we have so many PDFs around. And it certainly does an amount of AI to help you collaborate or work with those PDFs, and I find that very helpful, very useful in today's PDF generated era. So again, thanks for having me.
Awesome. Excited to hear from both of you today. So first, let's start with what's going on in the market. It's been an incredibly exciting month for AMD, your OpenAI partnership, your Oracle partnership, and of course your Helios product released today, last week at ACP, that 8,000-pound beast that, with our strength and our collaboration, we should talk about moving it around a little, but that's for our marketing teams to talk about. Sachin, why don't you share your views first on where the AI and data market is going?
Yeah, sure. I can start with the models because that's where it starts with, right? I mean, the models are the source of the intelligence and move through the value chains, basically in terms of what value they're creating in some sample customers, the adoption, the revenue growth, which is happening, and finally the infrastructure spend. So to start with the models as such, there are various benchmarks, like artificial analysis is one of those. That's third-party benchmark that benchmarks across various models, be it Grok, be it DeepSeek, ChatGPT, Claude, and so on. The key thing over here is that it benchmarks across various tests. Like you can have tests like HLE, humanities last exam. You can have various other exams which are there, which MMLU is another exam, ARC. So various exams which are there essentially. GPQA is another example. So the key point over here that's been noticed is that their intelligence scores, the model intelligence scores, are increasing from a gen on gen. Now, it may not be at the same rate as it was when it started. Of course, it starts tapering off a little bit, but the key thing is that it's still progressing moving higher and higher in terms of the scores. And that's very important because if of course, the model intelligence plateaus, then there's something to be concerned about, but it seems like it's still growing. And we see the impact of these models and the intelligence they have in the various use cases. For example, if you look at Klarna, that's a very popular use case where people have customer case study where close to around 700 customer service reps were essentially the model could do the work of close to 700 customer reps. That's where they Klarna integrated with ChatGPT. And another example is open evidence. That's in the medical field where essentially you have a proprietary LLM, and it's being used by close to 50% of the clinicians, the doctors and the nurses. And it's growing at around 50,000 subscriptions per month. Or if you look at Novo Nordisk, that's in pharmaceuticals, and close to 99.9% of clinical documentation time has been reduced because of using this LLMs. Or if you look at finance, Commonwealth Bank reduced their the scams were reduced by close to 50% using this LLMs. The key point over here is that it's across various industries, and it's creating a significant amount of benefit. It's not a little bit incremental, but it's a significant amount of benefit. And these are not isolated cases, as we can see from the user adoption. So a couple of data points. So for example, for OpenAI, there were 100 million weekly active users. I think it was in August 23. It moved to December, was around 300 million weekly active users. And then by that was December 2024, 300 million weekly active users. And then by February 25, it was 400. And then currently it's around 800 million weekly active users. So it's growing exponentially. And we can see that even in the growth in its revenues. So OpenAI's revenues grew in 23 from 300 million to 3.5 billion in 24 to currently at 25, it's tracking around 20 billion by the end of the year, anywhere 15 to 20 billion. And similarly for Claude, it grew from basically 100 million in 23 to 24 was 1 billion to 10 billion in 25 is what they're tracking. So the key thing is growing exponentially. And I bring OpenAI and Claude because this is the majority of the market as such from an end user perspective. So it's not about chips being sold to hyperscalers, but this is about end users actually using it. And that's more important, are the end users using it. So as we can see over here, there is a significant amount of growth, and that translates to infrastructure spending, which is the final piece of this, right? So Dell Oro, for example, is projecting close to 1.2 trillion by end of 2028, 50% for AI servers. And we also saw several spate of deals recently with OpenAI saying that they will invest, they will have a 10% investment for MI450s and Helioses, which will be sold to them. We also saw about OpenAI having investments, purchasing Broadcom or looking to purchase Broadcom close to around 10 gigawatts. So there are several such things which are happening, and that's the key thing is that AI is growing at a very rapid pace. And within AI, we should look at it as training and inferencing workloads. So training is growing roughly around 60% if you look at essentially the AI infrastructure space, the semiconductors. So roughly around $50 billion to $500 billion, which is what Lisa also mentions, which is CEO of AMD, and growing at around 60% overall, but 80% for inferencing. And that's a key factor because inference is growing at a very rapid rate. And a couple of other points, and I'll wrap it up, is we should look at Google, essentially, which grew essentially from 10 trillion tokens in 23, I think one quarter of 24 to 500 trillion in the first quarter of 25. And it's close to around a quadrillion. Most recent announcement by Dennis Hassabis, I think as of September 25, close to quadrillion tokens. So that's growing exponentially. And that's the same across you and other hyperscalers as well. So I think that's the key thing over here. And all this is translating to growth in storage also, which is also very apt over here, because we see that, generative Gen AI workloads essentially need close to around 5 to 8 times the storage on a per cluster basis compared to general purpose workloads. So these are in petabytes of scale compared to general purpose workloads, maybe in terabytes of scale. So it's really huge. And the multimodal and the agentic AI is only going to lead to further growth in storage. And we see that IDC projecting 25% growth in storage. Bernstein saying the same thing, around 25-30% growth in CAGR for storage from now to 2030. We also see that growing very rapidly. So that's basically, I would say, wrap it up by saying that there's a huge growth happening and across the entire value chain, starting from the model intelligence all the way to the infrastructure and the customer value add. Yeah.
Perfect. Thank you, Sachin. I'm very, very excited about how AI is making many of the industries more efficient. I think, you talk about data storage, and I'll hand over to Chris to talk about how we see the data market evolving. But I had a great conversation with someone the other day. I used to call data like the wheels on the car, data storage like the wheels on the car. But you only really noticed when the car broke down. And a dear friend told me the other day, it's all changed with AI. Data is now like the engine in the car. You can't go anywhere without it. So I think this collaboration is super exciting from that point of view. So Chris, do you want to share a bit about how we see the data storage market evolving for AI?
Yeah, I'm just going to offer some summary of it. Sachin had so many data points. Just to summarize of it. I mean, I think the biggest thing that you heard from Sachin is that we can do all of these models, but you need, just as important as the model is the data that feeds them. So now you're talking about over a quadrillion tokens per second at Google. That obviously is been trained on just a huge amount of data to feed the amount of users that are coming in. So that storage, that amount of storage and the performance of that storage really means that you need new storage. You need something more beyond general purpose storage that's been created for mostly enterprise applications. So one size fits all storage is just not going to cut it. You need high performance, scalable storage that can meet not only your requirements today, but what your requirements are in the future for both HPC and AI. I think the other thing is that as we sit here and use AI in all the different ways that we now use it compared to yesterday, and all the different ways that are coming tomorrow, really AI is redefining what is needed in the infrastructure, whether that's storage, whether it's GPU, whether that's networking, whether it's power. It's really defining and redefining what the data center looks like. So you need a data architecture and a storage architecture for that amount of concurrency, that throughput, to feed, as Sachin said, the end users that are using AI, and really, the embodiment of that is what VDURA and AMD have been working on together. So our reference architecture, is geared today and for tomorrow for those next generation AI workloads. So it's performant, it's validated, and ultimately what you'll hear about today is proven in production. So just to sum it up, that's my thoughts on the storage portion and really a little bit more of the data infrastructure part of the market.
Perfect. Thank you, Chris. So let's talk about the technology challenges. I think the market is growing at an incredible rate, and the numbers from Lisa Su and the market over the last few weeks have been incredible on the spend and infrastructure. And as you say, continuing to grow in training and growing even faster in inference. So Sachin, if you want to go first and share a little bit about how from the AMD point of view, you see bottlenecks or what is holding back the growth in the market today and what AMD is doing to really help resolve these challenges?
Yeah, I think some of the bottlenecks essentially, which is well known, is power constraints, right? We see that play out everywhere, and many of the commentators talking about power being a big constraint. And essentially, we see that IEA, which is International Energy Association, talk about how even the global power consumption is going at around 3%. For data centers, it's going at multiple times on that, around 4 times, 12% or 15% growth CAGR. And if you look at Morgan Stanley, they mention about specifically for generative AI workloads and not just overall data centers. They talk about how the power consumption needs is growing at 70% CAGR. So that is a big growth which is happening. And even other data points from McKinsey Uptime Institute mentioned that power being number one or number two cost driver for data centers, for AI data centers. So this is a very big aspect of it, because power is not growing at the same rate at which it's being consumed. As we see, power generation can maybe growing at maybe a couple of percentage, but the power consumption is, especially for data centers and AI, is growing at magnitudes of that, like 70% CAGR. That's a huge growth which is happening. And as a result of this, we want to have something which is going to provide high performance per watt, and that's a very critical metric. So the same power consumption, what is the performance output that can happen? And that's where AMD shines as such. That's one of the constraints, and we can talk about that a little bit in terms of how it actually adds value from an AMD's portfolio of products. But the other constraint which we are actually seeing, I think, is also storage. As I touched upon briefly, AI workloads essentially consume need close to around 3 to 5 times, or maybe even more, depending on the type of workloads on a per cluster basis compared to general purpose. And inference growing at an exponential pace, which I talked about in terms of a few data points, is leading to significant need for storage. And as an example would be a 1-minute video could consume around 1 gigabyte. A 1-minute video can be essentially done with a single prompt. So you're reducing the friction to create storage. That's the key thing. Agentic AI also is going to create a significant need for storage. And we see that briefly, it's not to that extent as power, but for example, HDDs, essentially TrendForce was talking about how the lead times have touched close to 12 months compared to what it would normally be for 3 to 6 months. That's in data centers. And HDDs account for 80% of the storage media type, 20% being flash. So overall, we see these are some of the big constraints. And I think both AMD from performance per watt, VDURA from its parallel file systems can definitely help to address these constraints that we see in the industry.
Perfect. Thank you, Sachin. Chris, do you want to speak a little, and then we'll jump to the architecture?
Yeah, Sam, your car analogy is actually pretty pretty parallel to the performance. So if you think about it, if your cars aren't quite, if your tires aren't quite balanced, or if they're out of alignment, you're not quite having the most efficient car, whether you're losing, you have less gas mileage. You could think of that with storage as well. So if you don't have not only the right tire, but it designed and installed and architected, just as that needed for the that infrastructure, that AI factory, that factory now starts to be inefficient, and that's one of the things that we excel at. So many, and unfortunately, a lot of AI initiatives you read, just fail to scale. They start small, and as they grow, whether that is an application issue, a storage issue, we see a lot of that on storage on our side. So the bottleneck is just being able to keep up with the pace that the AI market and its requirements generate. Not only just from year over year, but day over day. Really, performance is one aspect of productivity. So if you don't have enough throughput, if your storage solution isn't data aware, your inference, your training, your ultimately what the consumer is relying on for a positive outcome is is either going to be slow or is may not be exactly what their complete workflow needs. So you have to think about it from a performance and being able to scale. You know you uh, uh, AI is a very if you look at it in the technology life cycle, it's really a baby. But that baby is now growing up, and you need to grow with it, and you need to have a modern platform. So we here at VDURA have put mounds of time into modernizing our storage solution for AI optimized systems. So whether integrating compute, having the right networking in that single data platform, and then to help with that data pipeline. So really the by doing all of that, we are purpose building for AI and HPC, on top of our leading shared nothing architecture, combined running with AMD CPUs and coordination with GPUs and networking. That it's going to really accelerate your time to value, or customers' time to value. So I just love your car analogy, that if you don't have the right tires, a lot leads to having not a great drive. We want you to have the best drive possible with VDURA and AMD.
Excellent. Thank you, Chris. So I think Mike says it really well. Mike is our dear friend in AMD, works closely with Sachin, and recently gave us a statement for our press release of our infrastructure. And we are just so excited about our joint investment, and we really think about efficiencies. So, and in the GPU world, in the AI world, it's really about getting that data in and out of the GPUs as fast and as efficiently as possible. As you can tell, I'm very excited about it. I will hand over to Sachin to talk about why you're excited about the reference architecture, and then I'll ask Chris to talk through the reference architecture.
Yeah, sure. In terms of the reference architecture, I think one of the points that there are a few points which come across. One is that with VDURA you need essentially a thin client at the compute node. So essentially the resources can be dedicated to the GPU servers, and in doing so, you're able to get the full potential of the servers, because now it's essentially doing the work, allocating its power to doing work for the application rather than other paraphernalia. So that's one thing as such. And the second thing is that with VDURA, essentially you can scale as the data grows for the customer side. You can scale it with more storage servers, and very seamlessly you can scale it by just adding it to the storage, the network. And by even the same thing with AMD as well, you can add the GPU clusters, and by doing so, you can ensure that the performance is not deteriorated, but it scales linearly as well with the storage. So that is critical. And the other thing is also that customers who are implementing, they would, of course, look at variety of workloads. It's not just AI workloads. It could be HPC workloads. It could be other workloads. And that needs a general purpose GPU. So with AMD as such, you're essentially able to future-proof that for your end customer. Because the GPUs are well optimized for a variety of workloads as such. And with your ROCm library, you have a wide variety of functions and ready-to-use applications which are all there on Hugging Face, which the customers can use and get started very quickly. And I think also the final thing I would say is that VDURA is a technology where you can have a single namespace across, high-performance storage like SSDs, flash, as well as cost-effective storage like HDDs. And this is critical essentially because now you can have a single pipeline to fuel your GPUs. And that helps significantly in reducing operational overheads, improving throughput, and reducing the latency as well, and reducing the TCO. And I would also like to add that when you, for example, when you're doing, client is doing training or inferencing, You have multiple GPUs which are accessing the same data, and you want to ensure integrity checks. You want to ensure that there is no storage bottlenecks. You want to ensure that there is high throughput. All that is possible only because we are having the parallel file system from VDURA, and that helps even the GPUs to have a higher performance per output, and ensures that the utilization times are much higher than it would otherwise be without this. So those would be some of the points I would say.
Excellent. Thank you, Sachin. Yeah, I think talking to your team, even percentage improvements and efficiencies at the kind of scales that we're working with in the larger AI deployments makes such a huge difference for the customer, for the output, for that dollar per token or that ultimate metric. So let's jump into the architecture. So Chris, I'm excited for you to share a little bit about how we worked with AMD to really deliver a solution that customers can adopt easily, and it's already proven ready to work on their floor within days.
Yeah, first and foremost, if you want to see as much detail as possible on this, there is a reference architecture on, or this reference architecture is on VDURA's website. So please download and read all about it. Feel free to send us questions, whether now or after the webinar. I do also want to let people know that we're paying attention to questions. So as we get to either talking points or material, we'll answer your questions. So, but let's talk about that reference architecture. So again, Sachin said some points. I'll mention some more. It's a validated design. So you can see in that reference architecture, sort of starting points, performance points, and how we both scale from whether you deploy a minimum amount of GPUs or a massive AI factory worth of GPUs, and what storage or how much storage and what storage performance you would need from VDURA for that AMD cluster. The important point about it is it says optimized performance. So it's not just hooking up storage and sending storage over the wire. We're doing it at an optimized footprint, at an optimized performance. So you spend your money wisely on either how many GPUs you need or how much storage you need. It's scalable. So again, we can start small and grow that in multiple dimensions, from both networking, the compute GPU infrastructure or the storage infrastructure. You can grow that in a performance scale, as Sachin mentioned, or in a capacity scale, and you'll see a slide about that in a minute. And then the biggest thing is, or on top of that, is it's simplified. So not only do we have a reference architecture to help you get started, but also the installation time, yet time to first byte, but from both the application side all the way through the storage. We have both prescriptive configurations and the processes to get that deployment up and running as quick as possible. So a lot of detail is in further details in that reference architecture document. So from the VDURA side, there's so much information on AMD GPUs and CPUs. From the VDURA side, as Sachin said, we really have that software-defined data infrastructure, for AI and HPC. So whether that is high performance storage and utilizing SSDs, or that's bulk data, similar to an object store that you're storing petabytes and petabytes of data that you'll ultimately bring in for that training cycle. We can bulk store that in our data platform. So how we do that in both dimensions is a scalable, performant way. So and one of the coolest things that Sachin mentioned is that you can have a single data plane and a single control plane for both of these use cases. So for that high performance aspect to, during that training cycle, or if it's that data you don't need in your training cycle, you have a warm bulk tier, to maintain it close to that cluster, and then you can move it into flash and train on it. So we do that, and quite frankly, a very modern, easy, easy to install and easy to manage, infrastructure that you ultimately, work with us, work with AMD to ultimately put the right solution together.
Perfect. Thank you, Chris. I think there's a lot more detail we covered today, but we just want to give you a flavor. So on that flavor, let's talk about where we're working together. This is an exciting deployment we have in Germany, where AMD GPUs and VDURA storage come together. And then there's many other areas where we are working together in federal system integrators, in healthcare. We are incredibly excited about all the areas we cover together. But let's talk through this and why they chose to work with us. Chris, do you want to start and talk through, and then Sachin, maybe you can share about the AMD GPU deployment and then in other areas where you work with them.
Yeah, I'll certainly talk, mostly about the storage, but when you talk about use cases or organizations that that we work with a lot of academic research customers. One of them being Goethe University out in Germany. And why do we work with a lot of academic research institutions? That's ultimately where our next AI leaders and thinkers are going to be coming from. So we want them to to certainly be using AMD's latest generation of GPUs and compute and our storage to feed that. In particular, with Goethe, they implemented a certified hardware platform that we call V5000 alongside AMD GPUs that you'll hear more from Sachin about. So it's multiple petabytes. You don't have to start at the size of Goethe, but Goethe started at multiple petabytes, 20 petabytes. 2 petabytes of that are in high performance flash, and then the rest of that is on bulk disk storage. And one of the reasons why they chose us was for that flexibility. We delivered a pretty high performance initial starting configuration, over 100 gigabytes per second from a throughput standpoint out of that disk drives. You can get much more out of the flash layer, and this is standing up at Goethe now. But ultimately, what led to all three of us working together, is that combination of performance, that ease of use, that reliability. You hear us talk about it in terms of availability and durability. That they were frankly did not experience with their past storage system. So and what's really nice is that we talked about earlier about starting small and scaling, is that they're already working with us to expand that storage system as they expand their application side and alongside with additional GPUs to have a massive amount of storage in the future. So it's can start smaller than 20 petabytes. We'll talk about that here in a minute, but ultimately, the success is that we work with you. You have an optimal performance and simplified product that frankly is at the economics that you can afford.
Perfect. Thank you, Chris. And Sachin, do you want to share a little bit about Goethe and also other markets where we are being successful together?
Yeah, sure. So in Goethe, we essentially, from AMD point of view, we had MI300 GPUs. Now that is one generation older compared to what we have now, which is 350, which was just released. And then we'll have the MI450, which is next year. But for the MI300, the specs, there are a lot of specs for GPUs, but the key thing from performance are essentially you need compute output, So this was around 2.6 petaflops, that is MI300 for FP16. Now it can reach up to 5 petaflops for maybe around FP6, FP8, but essentially we want to have a balance between precision and performance. Then this is what is used, and it's around 2.6 petaflops, which itself is very high at that point in time. Now it's for 350, it's even more. The other important criteria is you need to have a HBM size, which is large. So it was 192 gigabytes HBM. And this is important because if you can store the models in your HBM, it's much more faster, so lower latency and consumes lesser power compared to going to the DRAM, for example, which takes significantly more, versus even SSDs, which takes even more longer than DRAM. So 192 gigabytes HBM, that was the capacity. And last important criteria is the bandwidth, the memory bandwidth. So that was roughly around 5 terabytes a second, 5.3 terabytes a second. So that's also important. So when the data is being transferred to the compute part or the chip on wafer on substrate. So that is basically what is important from your HBM to the compute. Now, the other aspect of it is that, so we have a very high performance per watt, as you can see, that is possible with this. And it works in conjunction with the other, aspects from AMD, which is CPUs as well. And if you also have DPUs and the networking. But the other important thing about this particular implementation is also that we were able to with the customized solution, wire the data from VDURA V5000 directly to the GPUs. So it's like GPU direct storage. Now you're able to bypass the CPU bounce buffers in doing so. And that essentially leads to a lower latency, of course, compared to going through the path from storage to CPU bounce buffers, and from there via PCIe to the GPUs. You can directly wire it to the GPU's HBM. And that leads to much faster, higher throughput, lower latency, of course, lower power consumption as well. That is very critical in these kind of implementations as well. And also, other aspect I would like to mention is that now that we have with ROCm 7, you have a wide variety of various functions, libraries, and ready-to-use applications as well, as I mentioned previously. But also want to bring it out over here because with this implementation, there was AI, there was HPC. So you have ready-to-use functions, ready-to-use libraries in your ROCm. And the advantage is that you don't have to start from scratch. The developers can get to the end product much quicker. So implementation time is reduced significantly. And more importantly, this is open source. So there's a lot of contribution that happens in open source much faster than in closed source. And also the fact that you don't have to pay for license fees. So that's another advantage which was possible over here. And I would say, I think one of the salient points of this was, I think, we saw close to 8.4 million IOPS, that's input-output operations per second. And that's basically, that's in conjunction with both AMD's compute as well as VDURA file system as well. Because if there was storage bottlenecks, if there was lack of data integrity, and poor throughput, then it will not be able to achieve that. So with the parallel file system, which is provided through VDURA V5000, we're bringing both hybrid and flash into a single namespace, we're essentially able to provide all aspects of it and reduce the TCO as well for the end customer. So I would say these were some of the points.
Thank you, Sachin. Thank you. It's such a technology-centric market. It's why I love it, but just the ability for AMD to focus on breaking through the bounds of technology and working with us to make sure we enable that from a data point of view is just so exciting. Our last question is actually very aligned to the first question we have from the audience. So if someone wants to start with a AMD GPU and a VDURA data platform, Chris, maybe you can start off here. Do they have, what sort of scale can they start? How can they try it out? Go ahead, let us know.
Yeah, so it's very important that we offer the ability to as you said, try out our file system. So we have a few options. So what's really cool about re-architecting our file system and making it more modern is that we have certainly allowed for that a small deployment size. Matter of fact, it is in just two 1U servers, in more of that proof of concept type of environment. You're able to have put as many clients as you would like. We would work with you on there is you don't need to put it on 1,000 GPUs, but and that allows you to see the simplicity, the deployment, the manageability of that system, and then to a degree an amount of performance, and then you can frankly you'll be pretty happy with that, and then you can scale that to a production system. We can start at 6U for an all flash system, and frankly a little bit more for flash and disk, but you can reuse that, so you don't return anything. You don't have to have additional budget for what you already paid for. You can reuse that and then scale to a production file system of the performance and capacity that meets what you're trying to deploy with AMD GPUs, CPUs, and networking. So again, we want to be able to be flexible to start small and then grow to your needs, whether now or frankly 5 years in the future. And then I'll let Sachin talk about how small you can get on the AMD side.
Perfect. Go ahead, Sachin, if you want to share, and especially I think I'm excited to hear some of your guidance on what people should think about when they're testing out an AI platform.
Yeah, sure. So I would say I would echo the points which Chris mentioned, and essentially I think the key thing is to you start with experimenting with certain workloads and scale it up from there before moving it into a production kind of environment. So you can experiment with some of the key workloads that you're looking for. It could be using the well-known. You can also use some well-known benchmark with Facebook AI similarity search, for example, or TPCX AI. That could be some of the benchmarks, and then compare how you perform versus others which have already been performed using those benchmarks. And more importantly, from an AI point of view, you can start with what would you look for from an end user point of view. So for example, what would be the size of the context window? That is critical as well. I mean, you cannot change that if you're looking for a pretty large context window where the user enters a prompt and then it has to go through the AI workloads, get the inference output, generate the inference output. So as part of that, then the key thing is also about what is the time for first token. So that's something which needs to be also experimented in terms of changing the compute requirements, changing the network configuration, changing the the storage requirement, flash versus HDD balance, which needs to be there. And that's also based on the number of concurrent users that you expect in your production environment. Of course, you cannot simulate that completely, but to some extent, you'll have an idea as you play around over here in the reference architecture point of view that what should be the time for first token when you have multiple users. And also more importantly is number of tokens generated per watt or tokens generated per dollar. So that essentially plays into the TCO, total cost of ownership. So balancing all these aspects, which essentially requires not just compute. Of course, compute is important. So you would have the CPU and the GPU from AMD, but also the networking is also important. So you can have, if you have a cluster, you can have ultra accelerator network from AMD. Of course, that is to be coming in 2026, but essentially with that, you can have close to around 1,000 GPUs, 1,024 GPUs in a coherent memory. So that basically means that you have more power. All of them behave like one single GPU with coherent memory. Or you also have the Pollara 400, which is basically based on ultra Ethernet consortium. And with that, you can scale it out even more to from 1,000, but it's close to 1 million GPUs. It can be scaled out. That would be production, but not in the labs as such. But just to give you an idea that you can use all of these portfolio of products, and not to mention the fact about DPUs also, wherein you can offload software-defined storage workloads to the DPU and accelerate it significantly, and you can achieve close to 40 times acceleration. And by doing so, you're freeing up the CPU for important application-related tasks and improving the CPU utilization. And overall, you're reducing the total cost of ownership. So all these aspects can be trialed out. And based on that, you can use what would be the to-be state template could act as what needs to go to the production as such. So I would say this would be some of the things that we should look at.
Thank you, Sachin. You touched on some incredibly exciting topics we are focused on for our next webinars and our technology collaboration. Networking is always the glue between storage and compute, and we are part of the Ultra Ethernet Consortium, and super excited to be collaborating with AMD and all the folks there. And then obviously your DPU acquisitions, very excited about how we can really accelerate that what we spoke about, getting data in and out of the GPUs as fast as possible. So incredibly excited about this partnership. I think we have time for maybe one question. I think we have one from the floor. If maybe Chris, you take the lead on this one. How easy is it to integrate VDURA with an existing AMD infrastructure?
It's a great question. Frankly, quite easy. So most likely that AMD base system is probably you talked about the network is probably an Ethernet base system. But whether it's Ethernet or another another high-speed networking, we can attach to that network to where that AMD cluster is, and then bring up our file system, install our client, our high performance client on that existing system, and quite frankly work with our team to a little bit of training, and frankly off you're running. So frankly it's one of the prouder things that we are able to do from our from a simplified standpoint, is that it'd be quite easy to stand up a system into existing or even new infrastructure.
Excellent. Thank you. Okay, I think we are coming up to time. Firstly, we appreciate everyone joining. So excited to see some of our partners out there, Penguin, Exact. We've got Aspen out there. Great to have you all join, and excited to work with you all on this blueprint we've created with AMD. Thank you so much, Sachin, and the whole AMD team. We're so excited to collaborate. The open infrastructure you all are creating, the incredible focus on performance and efficiency is just going to accelerate what's already an exciting market and helping us all every day. I think this is just the start. The blueprint for how we can start and scale is just the start. To your point, Sachin, the networking, the DPUs, all those exciting things that we can collaborate on, and how that's going to help not just training but inference. So calls to action, our partners out there, we would love to roll this out and with all your capabilities into the market. Customers, we would love to talk to you about your needs and how you can adopt AI into your infrastructure or scale your AI, or any inefficiencies you're seeing today. We are all going to be at Supercompute 25, and we're super excited to be there. So if that would be a great place to connect. So reach out, schedule a time with us, and thank you again for our speakers and for everyone joining. Have great days.
Thank you.